According to Japanese mythology, Raijin is the god of thunder, lightning, and storms. Always accompanied by Fujin, his brother, the god of wind. They live high above the clouds and control the elements. Raijin is often depicted beating his drum, summoning a treacherous storm, and luring a dragon from the darkness. There are many legends and stories that have tried to depict the atmosphere in the past. But how does it actually work? And how are we affecting it?
So the atmosphere is divided into what we call the troposphere. This is where all of our weather occurs. And the stratosphere is high up, 35,000 up to 100,000, 150,000 feet above us. So it's very high above us. But the stratosphere contains the atmosphere's ozone layer. And ozone screens solar ultraviolet radiation. That's dangerous, but fortunately we have ozone to absorb that ultraviolet radiation.
The ACCLIP is actually a very important region for this kind of studies because the rapid economic growth in China or in India. So this country has actually become very large producers of the ozone depleting substances. Although even though the actual controlled use of the ozone depleting substance has been coming down, but there's alternative replacement gases of these compounds. So those still remain as very active research area. So part of the ACCLIP team wants to understand is how much emissions of these gases coming from these developing countries in there, what's the percentage of them getting into the stratosphere and can be transported around the world to destroy ozone.
The ozone layer is a very important part of our atmosphere as it screens out ultraviolet radiation, harmful to all organisms on the planet. But there are other particles, called aerosols, that can also affect the climate and especially the Earth's energy balance.
About a decade ago in satellite observations, one of the things that was noted was an enhanced aerosol layer occurring within the Asian summer monsoon. And that enhanced aerosol layer is occurring because of the nature of the tropopause within the Asian summer monsoon at a high altitude. And so one of the questions is, as air leaks out or spills out of the Asian summer monsoon, how does that aerosol then translate and affect the overall northern hemisphere stratospheric aerosol burden?
But how do aerosol particles affect the Earth's radiation budget?
So within the climate system, stratospheric aerosol basically plays a role in the planetary albedo. How much of the sunlight that impinges upon the Earth gets reflected back to space. So we see this in periods when we have a large or multiple volcanic eruptions that put a lot of material into the stratosphere, and we see significant increases in stratospheric aerosol optical depth and the amount of aerosol in the stratosphere. We can tell that the impact on the climate from that is that a lot more light gets reflected back into space. That radiation being reflected back means there's less radiation reaching the Earth, and it has implications for surface climate.
So all the chemical compounds and gases that are transported into the stratosphere can have a major impact on our atmosphere.
15% of the northern hemisphere stratospheric aerosol burden comes out of the Asian summer monsoon. So that's not insignificant. So stratospheric aerosol has radiative implications for the climate system. And if the Asian summer monsoon is in fact a significant source of aerosol to the northern hemisphere, then it has a significant impact on the climate system beyond the nature of the sort of meteorological system itself.